Springfield, Massachusetts, March 1932. The grey brick facades of the Springfield Armory loomed against a brittle March sky, steam rising from the boiler stacks as the morning chill clung to the cobblestones. Inside the main workshop, a hum of industry permeated the air, the rasp of metal files, the rhythmic thump of hammers, the occasional hiss of compressed air. Among the scattered jigs and benches stood John C. Garand, 38 years old, resolute and methodical. His eyes traced the contours of a new semi-automatic rifle prototype, the wood-stocked receiver gleaming under the overhead lamps. Garand's hands, steady but calloused from decades of tinkering with springs and levers, lifted the rifle carefully. He squeezed the trigger in measured repetitions, listening for the telltale click of the internal mechanism cycling. "Precision," he murmured, almost to himself. "Every part, every inch, every pound of tension." The U.S. Army had learned bitter lessons during the First World War. Soldiers armed with bolt-action rifles like the venerable Springfield 1903 faced relentless waves of enemy fire, often pinned down while laboriously cycling rounds. By 1930, military strategists knew that the next global conflict would demand a weapon capable of delivering both rapid fire and pinpoint accuracy. A rifle that could sustain fire without exhausting the operator or sacrificing reliability in the field. Garand's goal was deceptively simple on paper. One man, one rifle, multiple aimed rounds delivered in quick succession without the cumbersome motions of a bolt-action rifle. But the mechanical reality was far more complex. Every component, gas piston, operating rod, firing pin, and receiver, had to interact with millimeter-perfect precision. Springs required exact tension. Tolerances could not vary more than a fraction of a millimeter, or the entire mechanism would jam under the stresses of combat. In the back of the workshop, a small team of machinists huddled over a partially assembled prototype. Their hands were smeared with oil and sweat. Their eyes focused on the alignment of the N-block clip system, a feature Garand insisted was the heart of the rifle's speed. This system, designed to hold 8 cartridges in a single metal clip, allowed soldiers to reload in seconds rather than the half-minute it took to manually load individual rounds. But every N-block clip introduced potential failure points, spring tension, feed angle, and ejector alignment, all of which had to be meticulously tested. "Try the second prototype on the range," Garand instructed. His voice carried authority, tempered by patience. "Record every misfeed, every hesitation. This rifle must perform under the desert sun, the winter frost, and the jungle mud alike." Outside the armory, the test range stretched in neat, sand-filled bays. Each target bore the marks of previous trials: ragged holes, splintered wood, and scored steel. Garand's aides loaded the prototype with 8 rounds, the metal clip clicking firmly into place. Garand assumed the firing stance, shoulder pressed against the stock, sight aligned along the target at 200 yards. The first round discharged with a sharp crack, the recoil absorbed by the carefully calculated spring tension. Immediately, the bolt cycled, chambering the next round with mechanical precision. Click, bang, click, bang. 5 rounds, 6, 7, each one delivering almost identical muzzle velocity and impact. Garand's eyes flicked to the target. The groupings were tight, far superior to most bolt-action rifles at the same range. A young lieutenant scribbled notes furiously. "Rate of fire is unprecedented," he muttered. "Accuracy remains within 5 inches at 200 yards. Garand nodded, but the satisfaction was tempered. The rifle was still temperamental. Fouling from black powder remnants clogged the action during extended firing, and certain clips misfed, under extreme conditions. And beyond the mechanical challenges lay the constant scrutiny of military bureaucrats. The War Department, cautious and fiscally conservative, demanded results without delay. Every month, Springfield Armory had to submit progress reports. "Will the rifle be ready for adoption?" they asked. "Can it survive prolonged field use?" Garand, however, knew that hasty approval could doom the project. Semi-automatic rifles had been attempted before, only to fail due to insufficient testing or fragile designs. The secret to the M1's success lay not in raw speed alone, but in harmonizing mechanical complexity with battlefield reliability. That secret, though unspoken in reports, was the precise timing of the gas-operated action. Unlike other semi-automatics that relied on recoil or spring momentum alone, Garand's design diverted a measured portion of expanding gas from the fired cartridge to cycle the bolt. This subtle innovation ensured that the bolt would eject the spent casing and chamber the next round without disrupting the rifle's balance or throwing off the shooter's aim. In practice, it allowed soldiers to fire successive rounds almost as quickly as they could aim, a feat unheard of in the early 1930 seconds. By late 1932, multiple prototypes lay on workbenches, each iteration improving upon the last. Garand would stay late into the evening, adjusting spring tension, testing different alloys for the bolt, and recalibrating the gas port dimensions. He maintained meticulous logs of every modification, knowing that future engineers would rely on these notes to reproduce the rifle en masse. Yet, the tension in the armory was palpable. Some military officials questioned whether a semi-automatic rifle, with its complex internal mechanics, could ever match the reliability of the familiar bolt-action Springfield 1903. Others worried about cost. Semi-automatics would be expensive, labor-intensive, and difficult to maintain in the field. Garand listened but did not yield. History, he believed, demanded innovation, not hesitation. By the end of the year, a breakthrough arrived. The 7th prototype demonstrated reliable cycling with all 8 rounds under extended fire tests. The unblock clip fed smoothly. The gas system operated without fail, and accuracy remained consistently superior to existing service rifles. Observers noted the rifle's speed, but the true secret, the precise interplay of gas pressure, bolt travel, and spring tension remained invisible to anyone outside the armory. It was a quiet revolution, mechanical and invisible, yet destined to change the battlefield. As winter melted into spring, the armory buzzed with cautious optimism. Garand, ever the engineer, continued to refine the rifle's internals, aware that perfection would not come easily. Around him, machinists and testers moved with the rhythm of purpose, aware that they were shaping the future of infantry warfare. Outside, the March winds swept across Springfield, but inside, the pulse of innovation was warming the old brick halls. The world would soon learn that the United States had conceived a rifle faster than any before, and that the secret to its speed lay not in flashy mechanics or brute force, but in the subtle, patient orchestration of moving parts, an invisible dance that only decades of engineering could choreograph. By the time the first production models rolled off the assembly line, the M1 Garand would carry this hidden advantage into battles no one yet imagined, a secret that would earn it the reputation as the fastest and most reliable service rifle of its era. Springfield Armory, June 1933. The sun beat down mercilessly on the outdoor range, the heat bouncing off the concrete and sand-filled target berms. Inside the small observation shack, John C. Garand watched as his latest prototype was prepared for another round of trials. The rifle, polished to a metallic sheen, rested in the hands of Sergeant Thomas Reynolds, a veteran of World War I turned armory test shooter. Reynolds' hands were steady, betraying none of the anticipation that ran through the team. "Remember," Garand said, voice clipped but controlled, "we're not just counting hits, we're counting cycles, misfeeds, and ejections. I want a full report on the first 100 rounds." Reynolds nodded, inserting a fresh N-block clip. 8 rounds, chambered and ready. Outside, wind whistled through the range, stirring dust and the faint tang of oil and gunpowder. The first shot rang out, sharp and precise. The bolt cycled automatically, ejecting the spent casing and chambering the next round. Bang, click, bang. The rhythm was mechanical, almost hypnotic. Observers noted the rifle's remarkable consistency. Even at an increased rate of fire, the groupings remained tight, rarely deviating beyond 3 inches at 200 yards. This was no ordinary semi-automatic. Earlier experiments with rifles from other nations had shown a tendency to jam after a few dozen rounds, particularly under rapid fire. Garand's innovation, the carefully calibrated gas port and operating rod, maintained a balance of speed and control. The rifle did not merely fire quickly, It maintained accuracy, ejected spent casings cleanly, and resisted overheating. By mid-morning, the team had cycled through over 500 rounds. Each clip was scrutinized after firing, springs measured, feed lips examined, and any irregularity logged. A small pile of spent casings accumulated in the sand pit, each one evidence of the rifle's growing reliability. Yet challenges remained. The Armory's early prototypes were sensitive to fouling. Black powder residue and early smokeless cartridges sometimes caused hesitation in the action. To address this, Garand began experimenting with variations in chamber dimensions and gas port diameter. He recorded the exact temperature and humidity of each test, knowing that a rifle that worked flawlessly in Springfield might fail in the jungles of the Pacific or the frozen European plains. At noon, a test was conducted under an unusual condition. The rifle was partially submerged in a shallow pool of water, simulating crossing a stream in combat. Many contemporary semi-automatic rifles had failed catastrophically under such circumstances, locking up entirely. Garand and Reynolds waited tensely as the first shot discharged. Water hissed against the metal, steam rising from the chamber. The bolt cycled perfectly. The second round, third, fourth, each fired without issue. Garand's eyes narrowed, but there was a glimmer of satisfaction. The secret gas-operated mechanism performed flawlessly even under duress. Later, the team moved on to endurance testing. Over the course of several days, multiple shooters fired thousands of rounds, alternating rapid fire with deliberate precision shots. Observers meticulously recorded misfires, jams, and wear on each moving part. By the end of the week, it was clear. The M1 Garand prototype outperformed every other semi-automatic rifle the Armory had tested. Its speed was unmatched, yet its reliability and accuracy remained intact. The data was logged and cross-checked against prior tests. Statistical analysis revealed a critical insight. The rifle's sweet spot for speed and control depended on the gas port, precisely diverting enough pressure to cycle the bolt without disturbing the rifle's alignment. Too little gas, and the bolt would fail to eject the spent cartridge. Too much, and recoil became unmanageable, throwing off aim. It was a delicate equilibrium, invisible to the casual observer, but critical to the rifle's performance. As evening approached, Garand gathered his team in the observation shack. He spread diagrams and prototype schematics across the table. "We are testing not just for the firing rate," he said, "but for the rifle's endurance, its ability to survive in combat, and its predictability under stress. This is what will make it the fastest rifle, yes, but also the most reliable." Private aides took notes as Garand detailed further modifications. Refinements to the N-block clip guide, slight adjustments to the extractor claw, and incremental changes to the gas cylinder. Each suggestion was tested the next morning in live-fire trials. This iterative process measure, adjust, test, measure again, was painstaking but essential. A breakthrough occurred on the 28th of June, 1933, during a simulation replicating battlefield stress. Soldiers fired at targets while moving, kneeling, and taking cover behind sandbags. The prototype M1 Garand continued to feed flawlessly, ejecting spent casings reliably and chambering the next round with a smooth, almost effortless motion. Observers recorded rates of fire exceeding 40 aimed rounds per minute, far beyond what any bolt-action rifle could achieve in the same conditions. Garand reviewed the test logs that night, highlighting a single note in his personal journal. "The rifle performs not because it is simple, but because every moving part is balanced. The secret is in the timing of the action, the invisible choreography of gas, spring, and bolt. This is what will make it unrivaled." Not all in the Armory shared Garand's enthusiasm. Some officials expressed concern about maintenance in the field, the cost of mass production, and the rifle's long-term durability. Garand responded calmly, citing the extensive trials and statistics. The rifle survived heat, cold, moisture, and continuous fire far better than existing designs. "This is not a toy for the workshop," he insisted. "It is a weapon for war, designed to give every soldier an edge in speed and accuracy." By the summer of 1933, Springfield Armory had solidified the M1 Garand's potential. It was no longer merely a prototype. It was a weapon nearing operational readiness. Garand continued his meticulous testing, fully aware that adoption by the U.S. Army would require overcoming bureaucratic inertia, production constraints, and skepticism from traditionalists. Yet the secret of the M1's speed, the precise engineering of its gas-operated action, the en-bloc clip, and the carefully measured bolt timing remained safely in the hands of its creator. It was an invisible advantage, a silent innovation that would one day prove decisive on the battlefields of World War II. As the sun set over Springfield, the armory's walls echoed with the quiet hum of metal on metal, the whispers of design, and the faint report of rounds still testing the boundaries of what was possible. The world had not yet seen the M1 Garand in combat, but in those tests, in that unassuming Massachusetts town, the fastest service rifle in the world was awakening. Fort Benning, Georgia, spring of 1934. The air was thick with humidity, carrying the scent of earth, gunpowder, and sweat. A small cadre of infantrymen had been selected to evaluate the M1 Garand under realistic combat conditions. Unlike the controlled environment of Springfield Armory, here the rifle would be tested in maneuver drills, mock assaults, and endurance runs that simulated the chaos of battle. Sergeant James Whitman, a seasoned NCO, inspected the rifles alongside Garand himself. "We'll see if this works when men are tired, moving fast, and under pressure," Whitman said, adjusting the sling on his test rifle. Garand nodded, attentive, taking notes on the rifle's serial numbers and noting any minor variances between prototypes. The first test involved standard marksmanship under duress. Soldiers fired from prone, kneeling, and standing positions, transitioning rapidly between stances while engaging multiple targets at varying ranges. The M1 Garand performed flawlessly. Its gas-operated semi-automatic action allowed each soldier to maintain steady aim while cycling rounds. Groups of 8 to 10 rounds remained tightly clustered at 200 yards, unprecedented for a semi-automatic of this era. Lieutenant Henry Marshall, observing the drill, remarked, "I've seen bolt actions that jam under similar conditions. But this maintains its pace and accuracy. The men barely break their sight picture." Next came rapid-fire trials. Soldiers engaged a series of steel silhouette targets, cycling through en-bloc clips under a strict time limit. The rate of fire far exceeded what any traditional bolt-action rifle could achieve. Observers recorded the average 35 to 40 aimed shots per minute per soldier without significant deviation or misfire. These numbers were more than theoretical. They represented a real advantage that could decisively impact battlefield engagements. Despite the promising results, there were still concerns. In prolonged firing, some rifles exhibited minor heating issues around the gas cylinder. Garand quickly implemented a solution: minor adjustments to the cylinder's venting and the addition of a reinforced operating rod sleeve. Subsequent trials demonstrated that the rifle could now withstand hundreds of rounds in rapid succession without overheating or losing reliability. Field mobility tests followed. Soldiers carried the M1 across uneven terrain, through dense woods, and across shallow streams. The rifle's balanced weight distribution slightly heavier than a typical bolt action allowed for stable aiming while moving. The semi-automatic cycle meant that each soldier could engage multiple targets without having to manually operate a bolt, dramatically reducing reaction time in simulated ambush scenarios. Private First Class Samuel Rhodes, assigned to carry the prototype, noted, "It's heavier than what I'm used to, but once you get the rhythm, it almost fires itself. You don't have to stop to work the bolt, it just goes." Garand observed each soldier carefully, noting their handling, grip, and interaction with the rifle. He recorded subtle insights: how the bolt's cycling speed could affect recoil management, how the en-bloc clip encouraged faster reloads, and how minor ergonomics adjustments could reduce fatigue over long marches. These details, while seemingly trivial, contributed to the rifle's overall battlefield superiority. A major milestone came during endurance trials designed to replicate weeks of continuous use. Soldiers carried their rifles, firing intermittently across simulated patrols, obstacle courses, and defensive exercises. After days of testing, the rifles remained operational. Springs retained tension, bolts cycled cleanly, and gas-operated mechanisms maintained consistent firing rates. This endurance validated Garand's claim. The rifle was not just fast, it was reliably fast under the most grueling conditions. Observers also compared the M1 to existing service rifles, bolt-action rifles, standard in U.S. infantry units, required manual cycling after every shot. Under duress, this often led to slower engagement and increased likelihood of misfires due to hurried operation. The M1, by contrast, allowed soldiers to maintain continuous fire, increasing both rate of engagement and overall combat efficiency. In one particularly illustrative exercise, 2 squads engaged a simulated enemy position. One squad, armed with bolt-action rifles, the other with M1 Garands, approached from opposite directions. The Garand-equipped squad consistently outperformed the bolt-action squad in terms of hits, speed of suppression, and ability to maneuver while firing. Observers noted that the difference was not marginal. It was a tactical advantage significant enough to alter the outcome of a small unit engagement. As the trials concluded, Garand convened the team to discuss lessons learned. "The M1 isn't perfect," he said, "but it achieves what we set out to do: deliver rapid, reliable firepower without sacrificing accuracy. Soldiers in combat will depend on it to outpace adversaries and respond faster than any bolt-action rifle allows." Official reports, meticulously compiled and sent to the War Department, emphasized the rifle's revolutionary potential. The combination of semi-automatic fire, robust engineering, and field durability positioned the M1 Garand as a transformative weapon for the U.S. Army. The secret principle, the precise synchronization of gas operation, bolt timing, and en-bloc clip feeding remained the key to its superiority, though few outside Springfield fully understood it yet. By summer's end, the trials at Fort Benning had conclusively proven the rifle's capabilities. Soldiers were confident, reports were glowing, and Garand continued his adjustments to optimize the final design. Letters from test squads to the armory praised the weapon, emphasizing its speed, reliability, and how it felt to wield something truly innovative. In quiet moments, Garand reflected on the journey so far. The M1 was more than metal and springs. It was a culmination of years of experimentation, sleepless nights, and meticulous engineering. And while the world had yet to see it in battle, one truth was clear: the fastest service rifle in the world had passed its first real tests, and no bolt action would ever outpace it again. Springfield Armory, late 1934. The atmosphere was a blend of precise mechanical order and quiet urgency. Workbenches were crowded with rifle components, some freshly machined, others in various stages of testing. John C. Garand moved from station to station, observing gunsmiths, inspecting finished parts, and meticulously documenting every adjustment. After months of field trials at Fort Benning, the M1 was close to its final form, but perfection demanded refinement. The most significant challenge remained the en-bloc clip system. Early designs occasionally failed to feed the last round reliably under extreme conditions. Garand, understanding the importance of uninterrupted fire, collaborated closely with machinists to tweak the spring, tension, feed lip geometry, and follower alignment. Each minor adjustment required repeated testing. Even a deviation of a fraction of a millimeter could compromise the rifle's flawless operation. "Gentlemen," Garand addressed the workshop team, "we're on the cusp of creating something the infantry has never seen before. Every round must feed, every shot must fire, and every soldier must trust this rifle implicitly." His words, though calm, carried the weight of years spent perfecting the gas-operated mechanism, a design that balanced the energy of expanding gases with precise bolt cycling. Simultaneously, attention turned to the rifle's stock and ergonomics. Soldiers in the field had praised the M1's balance, but noted minor fatigue during prolonged marches. Armory carpenters experimented with stock contours, adjusting the wrist grip, cheek rest, and shoulder recoil pad. Each prototype underwent extensive stress testing, repeated firing, exposure to humidity and dirt, and even intentional drops to ensure robustness under combat conditions. One breakthrough came with the refinement of the gas cylinder system. Early iterations sometimes led to excessive bolt velocity, creating a harsh recoil and accelerated wear. Garand's solution was both elegant and mechanical in nature, a precisely timed venting system that moderated the pressure of expanding gases, ensuring smooth bolt travel and consistent cycling. This adjustment became the secret heartbeat of the M1, the hidden principle that allowed it to outperform all contemporary rifles without sacrificing durability. At the same time, production planning became a priority. The U.S. Army recognized that the rifle's potential could not be realized if Springfield Armory alone manufactured the quantities required. Discussions began with industry partners, particularly Winchester and Remington, regarding tooling, quality control, and mass production. Garand insisted that tolerances remained uncompromising. A rifle that worked in a controlled armory environment but failed in the field was unacceptable. Throughout late 1934 and early 1935, iterative prototypes were sent back to Fort Benning and Aberdeen Proving Ground for final evaluations. Soldiers tested every conceivable scenario: mud, sand, extreme heat, cold, and prolonged exposure to rain. Reports consistently highlighted the same advantages: rapid semi-automatic fire, reliability under stress, and consistent accuracy. Each round could be fired without manual cycling, dramatically increasing engagement potential in small unit combat scenarios. The feedback loop between field trials and armory refinements exemplified a rare synergy between engineer and end user. Garand's philosophy was clear: a rifle must be designed around the soldier who will wield it. Every mechanical tweak, every contour of the stock, and every adjustment to the gas system was aimed at giving infantrymen a decisive advantage. By mid-1935, the final design coalesced into a weapon that was unmistakably revolutionary. The gas-operated action functioned seamlessly with the en-bloc clip, providing a controlled, consistent rate of fire. The rifle's weight and balance facilitated rapid target acquisition, and the robust stock and barrel could endure repeated use without degradation. In essence, the M1 Garand was no longer a prototype, it was a battlefield-ready instrument of war. However, the War Department's bureaucracy introduced its own challenges. Military officials debated the cost, production complexity, and training requirements. Semi-automatic rifles were more expensive than the standard bolt-action Springfield Model 1903, and some officers worried about soldiers expending ammunition too quickly. Garand, armed with detailed field trial data, presented compelling evidence. In simulated combat, the M1 consistently allowed soldiers to neutralize targets more quickly, with fewer misfires, and with greater reliability than bolt-action alternatives. By late 1935, the Army approved the M1 Garand for limited service testing. Springfield Armory ramped up production of pre-production rifles while engineers finalized documentation for large-scale manufacturing. Garand oversaw every step, from machining tolerances to final assembly, ensuring that the integrity of his design was maintained even as quantities increased. The rifle's secret, however, remained largely invisible to all but a few engineers: the precise interplay of gas pressure, bolt mass, and spring tension that allowed the M1 to fire faster than any bolt-action rifle without sacrificing durability or accuracy. While soldiers appreciated its speed, few understood the mechanical symphony within each rifle. It was a principle born of careful observation, relentless testing, and ingenious engineering, a principle that would define infantry combat in the years to come. By the end of 1936, the M1 Garand was ready for full adoption. The Army planned extensive training programs, teaching soldiers not only how to fire the weapon but how to maintain it in the field. Manuals emphasized lubrication points, cleaning procedures, and proper handling of en-bloc clips. Every precaution ensured that when the rifle reached frontline units, it would perform flawlessly. Garand himself felt a rare sense of accomplishment. Decades of experimentation, sleepless nights, and painstaking revisions had culminated in a weapon that combined speed, accuracy, and reliability. A true revolution in infantry firepower. Soldiers would soon carry it across training grounds, into the skies of distant battlefields, and ultimately into the annals of military history. As the first M1 Garands rolled off the Springfield assembly lines, Garand watched quietly, knowing that the secret heartbeat of his rifle, the subtle, elegant mechanism that allowed it to outperform every other service rifle, was now in the hands of soldiers who would depend on it for survival. The final stage was set. The fastest rifle in the world was ready to prove itself. Late 1941. As the world erupted into global conflict, the U.S. Army began the slow process of equipping frontline units with the new M1 Garand. Early deployments were limited, primarily to training divisions and select combat units preparing for overseas service. Yet, even in these controlled environments, the rifle's reputation began to spread among soldiers. At Fort Benning, Georgia, private recruits marveled at the speed and reliability of the semi-automatic weapon. Drill instructors, initially skeptical, found that men could engage targets more rapidly than with traditional bolt-action rifles. Sergeant Thomas H. Miller, a veteran of World War I, observed, "These boys can lay down more fire than we ever imagined possible. One man and one rifle, but the effect is like a squad of 30. Reports from the field highlighted the rifle's ability to sustain rapid fire without jamming, a critical advantage in close engagements and defensive positions. By early 1942, combat deployments began in earnest. Units destined for the Pacific Theater received M1s alongside the standard Springfield 1903. Soldiers trained vigorously in jungle warfare, learning to maintain the rifle in humid, corrosive conditions. The rifle's gas-operated mechanism, a source of meticulous attention by Garand and Springfield engineers, proved remarkably resilient. Even in tropical downpours, with mud and sand infiltrating the action, the M1 continued to cycle smoothly, earning the admiration of every soldier who fired it. Lieutenant James E. Carter, assigned to the 32nd Infantry Division preparing for New Guinea, wrote in his diary, "The men swear by the Garand. In live-fire drills, it never fails. The en-bloc clips make reloading faster than I imagined possible. I think this weapon will change the nature of our infantry engagements." His entry reflected what many officers began to understand. The M1 Garand was not just a rifle, but a force multiplier, capable of transforming how small units could engage the enemy. The rifle's performance was soon tested in combat scenarios. During the Battle of Guadalcanal, soldiers carried the M1 through dense jungles, rocky ridges, and sweltering heat. First-hand accounts described the rifle's rhythmic heartbeat, a nod to the gas system that moderated bolt speed and ensured reliable cycling. Soldiers quickly learned to appreciate the advantage. While Japanese Arisaka rifles required manual operation for each shot, U.S. infantrymen could fire repeatedly without interruption, maintaining a continuous line of defense or offense. Combat reports from the Pacific further underscored the rifle's effectiveness. The 13 Fighter Command, which coordinated infantry support, documented instances where the M1's rapid semi-automatic fire allowed small squads to repel numerically superior forces. One debriefing report from April 1943 noted, "Units equipped with Garands demonstrated markedly higher hit probabilities and maintained suppressive fire longer than units using bolt-action rifles. Enemy forces reported confusion and hesitation when faced with continuous volleys." These early successes foreshadowed the rifle's pivotal role in subsequent campaigns. Beyond raw firepower, soldiers also valued the M1's reliability under extreme conditions. Marine Corporal Edward K. Simmons recalled an engagement on Bougainville. "I was firing from a muddy foxhole, rain pounding down, and the rifle never faltered. I cleaned it afterward, and it was as good as new. You can feel the craftsmanship in every part." Accounts like Simmons demonstrated that Springfield Armory's rigorous design standards were not theoretical, they translated directly to survivability and effectiveness in combat. The M1's speed also transformed small unit tactics. Platoon leaders found they could suppress enemy positions quickly, allowing squads to maneuver with less risk. Fire discipline became critical. With a semi-automatic, capable of 8 or more rounds per clip, soldiers learned to coordinate bursts with precision. Tactical manuals, updated with M1-specific strategies, emphasized controlled volleys, proper cover utilization, and rapid reloading techniques. In essence, the rifle reshaped doctrine as well as battlefield outcomes. Despite its advantages, the M1 was not without challenges. Early unblock clips were sometimes lost in the chaos of jungle warfare, and supply chains had to adapt to the rifle's specific ammunition needs. Officers also reminded soldiers that rapid fire could lead to overheating barrels if sustained for extended periods. Nevertheless, these issues were minor compared to the overall combat advantage the rifle conferred. Every report emphasized one point: in trained hands, the M1 Garand dramatically increased infantry lethality. The rifle's reputation eventually reached the attention of Japanese forces. Interrogation reports from captured officers in late 1943 noted that U.S. infantry units often fired with a speed and rhythm that made our defensive positions untenable. Post-war analyses corroborated these claims, confirming that the M1's semi-automatic design directly contributed to American tactical successes in the Pacific. Historians would later highlight the rifle's impact as a critical factor in the U.S. Army's ability to execute combined arms operations with infantry at the forefront. Back at Springfield Armory, John Garand received early battlefield feedback with quiet satisfaction. Letters from soldiers and officers described the rifle's performance in detail, often highlighting moments of decisive action made possible by its rapid-fire capability. Engineers monitored these reports closely, noting opportunities to refine manufacturing techniques and ensure consistent quality across production lines. Garand, however, remained focused on the original design principles: mechanical reliability, ergonomic comfort, and the unique gas-operated system that set the M1 apart. By the end of 1943, the M1 Garand had proven itself in multiple theaters of war. From the jungles of New Guinea to the islands of the Solomon Chain, the rifle's combination of speed, accuracy, and dependability earned the respect of every soldier who carried it. Its secret, a precisely engineered mechanical rhythm that allowed semi-automatic fire without sacrificing durability, had translated from the armory's meticulous prototypes to the harsh realities of combat. In retrospect, these early deployments confirmed what Springfield engineers had long anticipated. A rifle designed around the principles of reliable semi-automatic fire could redefine infantry warfare. Soldiers would fight differently, tactics would evolve, and the battlefield itself would change under the influence of the M1 Garand. Its legacy, already forming in the memories of frontline troops, was only beginning. By 1942, the U.S. Army faced a pressing logistical challenge: how to supply thousands of frontline troops with the revolutionary M1 Garand. The rifle had proven itself in early combat deployments, yet production remained slow. Springfield Armory, with its long history of small-batch, precision firearm manufacture, was not equipped for the enormous scale required by a global conflict. The U.S. now faced a race: expand production without compromising the mechanical integrity that made the M1 exceptional. John C. Garand understood the stakes. He visited the assembly lines daily, inspecting parts and ensuring tolerances were met. Every bolt, receiver, and gas cylinder had to operate flawlessly. The rifle's semi-automatic mechanism would fail if even minor deviations occurred. Garand's meticulous attention to detail had created the weapon's secret advantage, its ability to cycle reliably under sustained fire, and he was determined to preserve it, even as output increased. To meet the demand, Springfield Armory partnered with private manufacturers under the Lend-Lease and Arsenal of Democracy programs. Companies like Winchester, International Harvester, and Harrington and Richardson were contracted to produce the rifle at unprecedented volume. Engineers faced a steep learning curve. Precision machining techniques had to be adapted to mass production, and assembly workers, many new to firearms, needed thorough training. Each rifle underwent rigorous quality control, with inspectors checking mechanical operation, gas system function, and accuracy. The slightest flaw could render a weapon ineffective in combat, and Garand refused to compromise on standards. Industrial innovation became critical. To streamline production, new jigs, dies, and inspection protocols were developed. Workers in factories across the U.S. were trained in standardized assembly procedures, often repeating the same motions hundreds of times per day. Despite the monotony, morale was high. Everyone understood that each rifle leaving the line could save a soldier's life. In his diary, Garand noted, "The challenge is not merely to make rifles, but to make rifles that will function perfectly in the hands of men facing life or death. Our country demands nothing less." By mid-1943, production accelerated dramatically. Springfield Armory and its partners were producing tens of thousands of M1s per month. The rifle's unique en-bloc clip system facilitated rapid reloading in battle, but it also required careful standardization in manufacturing. Clips had to fit precisely. A loose or tight fit could impede cycling. Engineers worked tirelessly to ensure that every component met exacting specifications. This combination of precision engineering and industrial scale was unprecedented and became a hallmark of the U.S. wartime production effort. Meanwhile, logistical planners faced the challenge of distributing the rifles overseas. Ports on the east and west coasts handled massive shipments to the Pacific and European theaters. Units undergoing training had to receive rifles along with ammunition, spare parts, and maintenance manuals. Training programs emphasized proper care of the semi-automatic system, ensuring soldiers could maintain reliability in harsh conditions. Reports from the field praised the efforts. Soldiers arrived with familiarity and confidence, reducing early mechanical failures in combat. The M1 Garand quickly became a symbol of American industrial power. Magazine articles and army bulletins highlighted its combination of cutting-edge design and mass availability. Field officers reported increased morale among troops who carried the rifle. Lieutenant Colonel Robert J. Harper, in a 1943 report from Guadalcanal, observed, "The Garand has become more than a weapon. It is a confidence builder. Men know they can rely on it. Its rapid fire allows squads to maneuver aggressively, something previously impossible with bolt-action rifles." These testimonials reinforced the Army's strategic commitment to full-scale deployment. Production challenges persisted. Some factories struggled with maintaining tolerances, while others experienced bottlenecks in raw materials like high-grade steel. Yet the Army and contractors solved problems with inventive solutions. Alternative suppliers were identified, specialized machining techniques were refined, and inspection protocols were tightened. By the end of 1943, U.S. factories were producing more than 500,000 M1 Garands annually, a staggering achievement given the rifle's complexity. The M1's proliferation transformed training and tactics. Infantry units equipped with the rifle could conduct sustained suppressive fire, coordinate rapid advances, and maintain defensive positions more effectively. Soldiers appreciated the reliability of the gas-operated action, which allowed semi-automatic cycling even after extensive firing. The rifle's ergonomic design balanced weight, comfortable stock, and smooth trigger reduced fatigue during long engagements. Reports from the 13 Fighter Command and other combined arms units confirmed that these factors materially increased combat effectiveness. By 1944, the M1 Garand was standard issue across U.S. Army and Marine Corps units. Its presence on the battlefield symbolized both technological innovation and the industrial capacity of the United States. The rifle's secret, the precise mechanical harmony of gas operation, en-bloc clip feeding, and component reliability, was now available to every frontline soldier, creating a decisive advantage over enemy forces still largely reliant on bolt-action firearms. Springfield Armory and its partners had achieved what many had thought impossible: the mass production of a complex, highly reliable semi-automatic rifle. In the process, the M1 Garand became more than a weapon. It became a testament to American ingenuity, industrial might, and the careful balance between engineering excellence and manufacturing pragmatism. Every rifle shipped overseas carried not only bullets but the promise of firepower, reliability, and survival for the soldiers who wielded it. In retrospect, the rapid expansion of M1 production demonstrated a key lesson of World War II. Technological superiority alone is insufficient. Only when combined with industrial capacity, logistical coordination, and rigorous quality control, could a weapon truly influence the outcome of war. The Garand exemplified this principle, bridging the gap between innovation and practical battlefield application. By late 1943, the M1 Garand had fully arrived on battlefields across the Pacific and Europe, transforming the experience of infantry combat. Soldiers quickly learned to trust its reliability, rapid-fire capability, and precision. Its semi-automatic action gave U.S. troops an unprecedented edge over opponents still relying heavily on bolt-action rifles like the Japanese Arisaka or German Mauser. Reports from frontline units, combined with combat diaries, highlighted the Garand's decisive role in both offensive and defensive operations. On Bougainville in the Solomon Islands, Private First Class Henry McAllister of the 1st Marine Division recalled the rifle's effect during a Japanese counterattack. Facing an enemy entrenched on a ridgeline, McAllister and his squad found that the Garand allowed them to maintain suppressive fire while maneuvering around flanks. With the Garand, I could fire as fast as I could aim, and it never jammed, he wrote in a post-war memoir. It felt like I had twice the firepower of the men on the other side. That rifle saved lives that day, mine included. The rifle's semi-automatic operation also changed squad tactics. Platoon leaders in Europe noted that soldiers could provide sustained covering fire without waiting for bolt-action rifles to cycle. In the Italian campaign, Lieutenant Colonel William H. Graham of the 34th Infantry Division observed that squads armed with Garands could hold defensive positions against larger German forces, relying on continuous fire to disrupt assaults. The en-bloc clip system allowed for rapid reloading under fire, further increasing battlefield effectiveness. In addition to tactical advantages, the Garand built confidence among inexperienced soldiers. Many young recruits arriving in the Pacific had little familiarity with firearms beyond basic marksmanship. The M1's straightforward operation pulling the trigger for semi-automatic fire, easy loading via the 8-round en-bloc clip, enabled soldiers to focus on aiming and maneuvering rather than worrying about jams or complex maintenance in combat. During amphibious assaults on islands such as Tarawa and Peleliu, infantrymen frequently cited the Garand as a critical tool in overcoming entrenched defenders. Accounts from the European theatre also reinforced the Garand's legendary status. During the Battle of Normandy, Sergeant Thomas R. Collins of the 29th Infantry Division wrote in his journal, "The Germans kept trying to push us back with their rifles and machine guns, but the Garand allowed our squad to fire rapidly, suppressing their positions while our artillery prepared to strike. I can't imagine holding our line without it." The rifle's reliability in the rain-soaked hedgerows and muddy trenches of Normandy earned it the nickname the infantryman's friend. The M1's durability was especially praised in harsh environmental conditions. In the Pacific, soldiers reported that salt water, sand, and mud often caused other rifles to malfunction. The Garand's gas-operated system, combined with the carefully engineered tolerances of its components, enabled it to continue cycling under conditions that would immobilize a bolt-action rifle. Lieutenant Samuel H. Dorsey, serving in New Guinea, noted during an inspection report that troops fired hundreds of rounds in the mud and heat, yet rifles continued to function without misfire. The Garand is a marvel. Stories of individual heroism also highlighted the Garand's role in combat outcomes. Corporal James R. Mackenzie, in the Pacific Campaign, recalled a firefight where he alone held a hilltop against a Japanese platoon. Using rapid bursts from his M1, he maintained enough suppressive fire to allow reinforcements to arrive. "I could fire as fast as I could squeeze the trigger, and the rifle never let me down." The Japanese underestimated what one man with the Garand could do, he wrote in his post-war memoir. Reports like these circulated in letters home, army newsletters, and eventually historical accounts, cementing the rifle's reputation among both soldiers and the public. The M1 also influenced combined arms operations. Coordination between infantry, artillery, and air support relied on effective infantry firepower. Garand-equipped squads could hold objectives while artillery bombardments were arranged or airstrikes were called in. Combat reports from the 13 Fighter Command and Pacific Task Forces repeatedly cited infantry units' ability to maintain positions due to the rifle's semi-automatic capability. In one debriefing after a night engagement in the Solomon Islands, a battalion commander emphasized that the Garand allowed small units to provide covering fire comparable to what would have previously required multiple squads. It changed the dynamics of the battlefield. Beyond individual engagements, the Garand's presence influenced enemy tactics. Japanese and German forces, encountering rapid semi-automatic fire, had to adjust assault formations and defensive positions. Interrogation reports from captured soldiers noted surprise at the volume and speed of American rifle fire. Japanese officers later admitted that encountering Garand-equipped units disrupted their usual bolt-action tactics, forcing them to adopt more cautious advances and defensive measures. The rifle's performance directly affected combat planning on both sides. By the end of 1944, the M1 Garand had solidified its place as the iconic rifle of the U.S. Army. Its combination of mechanical innovation, mass production, and battlefield effectiveness represented a triumph of engineering and industrial organization. Soldiers across theaters carried it with pride, and historians later recognized it as a key factor in the United States infantry superiority. Personal accounts, official reports, and post-war analysis all point to the rifle as not merely a tool, but a strategic asset, whose reliability and speed transformed the nature of combat in World War II. Even decades later, veterans' reunions featured stories of the rifle in action. Men who had faced impossible odds credited the Garand with saving lives and allowing small units to accomplish missions that might otherwise have failed. Its combination of speed, accuracy, and durability created legends that persisted long after the war, reinforcing the idea that technological advantage, when paired with skilled soldiers and effective tactics, could decisively influence the outcome of conflict. The battlefield legacy of the M1 Garand was clear. It was not simply a faster rifle, it was a force multiplier. Its secret mechanical principle, the harmony of gas operation and en-bloc feeding, proved its worth in thousands of engagements, earning it the respect of soldiers, historians, and engineers alike. In the hands of American infantrymen, the Garand became a symbol of reliability, ingenuity, and the nation's industrial and military strength. The end of World War II brought sweeping changes to the global military landscape, and the M1 Garand remained at the forefront of discussions about infantry weapons. As soldiers returned home and military planners assessed the lessons of the war, the Garand emerged as a benchmark for semi-automatic rifle design and a symbol of American industrial and technological prowess. Its combat record and innovative mechanics became the foundation for post-war small arms development. In Europe, U.S. forces occupying Germany reported that captured German soldiers were often surprised at the sheer volume of fire the Garand could produce. Interrogations and intelligence assessments revealed that the semi-automatic capability had forced adjustments in German infantry doctrine, with units reconsidering exposure in open fields and advancing cautiously against well-armed American squads. Such reports influenced U.S. post-war military thinking. Planners recognized that superior rate of fire, combined with reliability, was decisive not only tactically but psychologically. The rifle's post-war legacy extended to training and doctrine. The U.S. Army instituted formalized marksmanship programs centered on semi-automatic weapons, emphasizing rapid but controlled fire. Training manuals highlighted the importance of the en-bloc clip system, gas-operated reliability, and the ability to maintain fire under combat conditions. By 1946, newly minted officers and NCOs were educated in the principles that had made the Garand effective in battle: speed, precision, and mechanical simplicity. The rifle became an educational tool in itself, teaching soldiers the value of engineering elegance in combat. Industrial lessons were equally important. The Lockheed-designed P-38 aircraft had demonstrated how innovative engineering could yield tactical advantages in the air, and the M1 Garand did the same on the ground. The successful mass production of a mechanically sophisticated rifle proved that U.S. industry could simultaneously meet high-quality standards and scale output. The Springfield Armory's production records highlighted the unprecedented coordination between engineers, machinists, and logistics officers. Post-war weapons programs, including the M14 and later the M16, directly benefited from these production and design principles. The Garand also influenced international military thought. NATO planners and allied nations studied its design to inform their own infantry weapons programs. The British and Canadians examined the rifle's semi-automatic action when developing post-war self-loading rifles, while German engineers, in post-war re-evaluation efforts, analyzed captured M1s to inform the development of their own automatic and semi-automatic rifles. The principle of a gas-operated mechanism, paired with simple yet robust feeding, became a universal design philosophy in small arms engineering. Veterans organizations kept the Garand's legacy alive in civilian and military culture. Reunions, memoirs, and historical associations frequently highlighted the rifle's role in pivotal battles. The Smithsonian National Air and Space Museum, in partnership with the National World War II Museum, curated exhibits emphasizing the rifle's mechanical innovations and battlefield impact. Visitors could see firsthand the balance between engineering precision and battlefield practicality that had defined the M1 Garand. Exhibits emphasized how the rifle represented not only American ingenuity, but also a practical solution to the challenges of modern warfare. The rifle's enduring presence extended beyond military museums. Competitive shooting leagues in the post-war era adopted the Garand for marksmanship competitions, celebrating its precision, reliability, and historical significance. Its popularity among collectors and enthusiasts reinforced the notion that the M1 was not merely a relic, but a standard against which all semi-automatic rifles could be measured. The gun's reputation as the fastest rifle in the world persisted, grounded in factual performance metrics verified during wartime testing and post-war evaluations. Technological lessons from the Garand informed Cold War-era rifle development. Army began conceptualizing a lightweight, high-capacity service rifle. Engineers referred to the M1's gas-operated mechanism and N-block feeding system as a starting point. The design principle of combining rapid semi-automatic fire with robust reliability remained a guiding framework. Even as new calibers, materials, and manufacturing techniques emerged, the underlying philosophy pioneered by Garand, mechanical simplicity, enabling maximum battlefield performance, remained influential. The Garand also left a strategic legacy in military doctrine. Commanders understood that weapon performance could dramatically alter unit effectiveness. Infantry squads equipped with fast, reliable rifles could hold terrain, suppress larger enemy forces, and execute complex maneuvers with fewer men. This lesson carried into the Cold War and subsequent conflicts, shaping the way the U.S. military approached infantry armament, training, and tactical planning. On a cultural level, the M1 Garand became an icon. Films, books, and documentaries celebrated the rifle's role in World War II, portraying it as the tool that empowered soldiers to achieve remarkable feats under extreme conditions. The phrase, "the fastest rifle in the world," entered public consciousness, often cited by veterans and historians alike. Unlike many military technologies that fade into obscurity after conflict, the Garand's legend endured, representing a convergence of engineering brilliance, industrial capacity, and combat effectiveness. By the 1,960 seconds, formal evaluations of small arms effectiveness consistently ranked the Garand among the most influential rifles of the 20th century. Its operational reliability, speed of fire, and influence on tactics set benchmarks for future designs. Scholars and military analysts studied battle reports, veteran accounts, and engineering documents to understand why the M1 Garand had outperformed both contemporary and earlier rifles. Its combination of innovation, practical utility, and battlefield impact made it an enduring subject of study. Ultimately, the Garand's legacy is more than technical. It embodies a philosophy of designing for the soldier, creating weapons that are reliable under pressure, easy to use, and tactically advantageous. It reminds engineers, planners, and historians that a single mechanical innovation, executed with care and foresight, can alter the course of battles and define the effectiveness of entire armies. The secret that made it the fastest rifle in the world, a precise, gas-operated semi-automatic action married to the en-bloc clip system, proved that thoughtful engineering could turn a firearm into a decisive instrument of war. Even today, decades after its introduction, the M1 Garand remains a symbol of American ingenuity, a testament to industrial skill, and a living reminder of the soldiers who carried it through the most grueling battles of World War II. Its story, from Springfield Armory to battlefields across the globe, continues to inspire designers, historians, and veterans alike, embodying the enduring power of innovation combined with practical necessity.